This lesson is all about environmental engineering, the role engineers and scientists play in protecting our environment and minimizing the impact we have. Some of the ways we measure that, we have some experiments on different things like acids and bases, and we talk about water filtration. We talk about how, again, resource efficiency can minimize our impact on the environment and how different processes can clean up the waste that we create. After speaking about all the other natural resources, we move on to water and how responsible management of water is really important. We talk about how we make water safe for drinking, and we also talk about how we dispose of wastewater safely. This activity is building a water filter. So we have two different size cups. One will act as a means of holding onto our filter paper and filter materials. The other will be used to catch what comes out below, like so. We have gravel, filter papers. We have tea bags here to add some dirt to the water. So you can use a compass or something similar, something with a sharp edge, to put holes in the bottom of the cup like so. I've used a skewer here, which didn't work particularly well, but every child in the classroom should have a compass. So the basics of your filter. Your filter paper. So what I've done here is I've added the cotton wool. This will make up the bulk of your filter, and this catches all the small pieces. What I'm adding on top is some gravel. Now, if you want to see really good results from the start, what I would recommend is rinsing this gravel, or else using something maybe that doesn't have any residue, maybe the rice, for example. But the first time you wash with this filter, it's likely that some of the dust from the gravel will make its way down and into the cup, which some kids might be disappointed with. But the gravel serves to hold down the cotton wool, and so we put that in on top. Once you get it down, get a nice layer. Something like this. Try and press it to the sides. So push all out to the sides, and that means any dirt that goes through will get caught. And we'll try go for something of a demonstration here. So our tea bag acts as our dirt. Whoa. There may also be sachets of salt and pepper, other pieces. The idea here being, once you pour through your filter, all that nastiness gets caught at the top. Put some more water through to see some results. And you'll have your water fall through. One thing to note is that as this is coffee filter paper, the actual pores are not so small as to stop all particulates coming through. So for example, if you're making your cup of coffee, as this is designed for, you want some amount of small pieces to go through, hence the colour of the water. So you'll have all of the larger pieces caught, but the water will still be a different colour. That depends on what you use to dirty up the water. If you used, for example, rice, the reason I don't usually use rice is it's large particles and the kids can often see it getting caught. Use tea, it's a lot more kind of visually impressive, but you do end up with a small bit of a colour. For fear of this activity being too short, one thing to do is to try and test the limits of your filter. So we've seen that tea produces particles that will give it a colour. Maybe try and find other things around the classroom, like I said, or salt or pepper, and see what effect they have on the filtrate, which is the water that comes through. So further to that, we have an example or a sample of oil. So the trick thing with oil is it's a non-miscible, it's immiscible, and so when you add some to the water, our filter should be quite adept at removing it. So put that through. And so in the process of testing what our filter can and can't work with, we should be able to find out that oil sits on top here and gets caught very well by the filter. So in the second activity, what we're going to try and do is create some mixtures that are acidic and basic and get the kids to test them. And the idea is that they will go out and test water samples to see what the properties are in the same way that an environmental engineer might do so. So you're going to need a couple of cups. We have baking soda, vinegar, and some spoons. From the outset, it's important to know what you kind of want to achieve here. So sometimes it's happy or handy to have two kids go away and think about it while two kids prepare the solutions, and then the two kids that have stepped away can come back. They don't know which is which and they have to figure out using litmus paper. If all kids are present when the mixtures are being made up, the chances are they're going to know which is which, and it kind of maybe takes away a bit of the fun. So have teams of 4 as usual. 2 guys will make up the solutions, 2 guys will volunteer to step away, and when they come back they'll use the litmus paper to try and figure out which is which. So I'm just going to make up the solutions now. Don't use too much baking soda, and make sure you give it a really good stir so that the solution will be colourless. If you put in too much, you'll see sediment at the bottom, and then it's quite easy to guess which is which. So there are our 2 samples. So leave the slide on the board in terms of what paper does what. So here we have a sample of red litmus paper, samples of blue. So if you don't know which is which, you can take your red litmus paper, and in an acid it won't change. So you should take red, I know if it goes in here, turns blue. Vice versa now, so if you take your blue, it should do nothing in a base, and it will turn red in an acid. Once they've discovered the solutions are absolutely fine to handle, none of them are too dangerous, you can kind of mess over back and forth and try and see, can you get papers to turn again. So we're trying to, that's turning back to blue. If you're using an acid now, then get some color changes. Let this guy go. And done. So by dipping the different litmus papers in the different samples, we should figure out which is which. Just to run through again, red litmus paper dipped in acid stays red, dipped in a base turns blue, and vice versa. Blue litmus paper dipped in a base stays blue, dipped in acid turns red. Okay, so over that lesson, the kids should have learned all about water engineering, about, say, the impact we have on the environment and how to minimize it. We did some lessons, so we looked at the capabilities of filters, so how it's able to remove things like oil and maybe large particles, but it's not able to remove salt or things that have dissolved. We tested 2 samples of solutions to find out whether it was acidic or basic, as an environmental engineer might do in the field. Check the slides for next week's lesson, and thank you very much.